All right, let's take a look at the checkpoint questions for module number 2. So this first question here asks us to set up this system of equations as a matrix by hand and solve it. So let's walk through that. So first thing we need to do here is to build this matrix up. So we're going to take our 3 equations, write this as an augmented matrix. So so when you're setting up a matrix, it's really important to keep all the variables in order. So for these first 2 equations, that's not terribly hard to do, but I'll point out the kind of the tricky thing to look at for the third equation. So my coefficients of x, y, and z in that order are 2, 5, and 1. Then for the next equation, they're -1, 4, and 3. For the last equation, there is no y term. So how do we handle that in a matrix? Well, we still have to have a placeholder for the y. So we'll call that a 0. The coefficient of y is effectively 0, which is why there's no y term there. And the coefficient of x is 5, coefficient of z is -2. And I also want to write down basically the right-hand side of the equal signs for all these equations. So let's remind ourselves kind of what the finish line looks like here. So I want to get a matrix whose, first 3 columns look like this. 1, 0, 0, 0, 1, 0, 0, 0, 1. And once I do all the right manipulations to get the first 3 columns of the matrix to look like this, so whatever winds up in the 4th column, those are going to be my solutions to the system. So once I get this kind of these 1s down this diagonal and 0s everywhere else, that'll tell me basically x equals a, y equals b, z equals c. That'll be our solution. So first thing we're going to try to march toward is getting a 1 in this top left entry here. So one thing I'll point out is that the way I solve this is probably going to be different from all of you. Many of you are going to be different from each other. But yeah, here's one way you can go about this. The first thing I'm going to do here is, in order to get a 1 in that first row there, I'm going to do this. I'm going to swap the first row and second row. Because if I can put a -1 there, so again, switching the first 2 rows and just rewriting the third because I'm not doing any alterations with it. So if I want to get a 1 there, one thing I'll point out is when you're trying to put a 1 in those positions, it's usually best to deal with that row and no others. So is there something I could multiply this row by and get a 1 there? So what can I multiply -1 by to put a 1 there? I can multiply that by -1. So let's organize here. I'm going to take negative row 1 and simply put that back into row 1. So what does row 1 look like if I do that? It's going to be 1, -4, -3, and then +4. And the bottom 2 rows are going to be unchanged. All right, so I got a 1 in the first position. Now what I want to do is get zeros below it. So how do I do that? Let's get that 2 and clear it first. So I'm going to take row 2 and subtract 2 of row 1 because I want to subtract enough 1s to get to clear that 2 and make it a 0. So I'm going to take row 2, subtract 2 row 1s from it, and then put that result back into row 2. So one thing I'll point out is that right now is that I'm only altering row 2. So I'm going to put row 1 and row 3 just back in place. I don't like that it connects the top of that 4. 4. 5, 0, -2, -13. All right. So row 2 minus 2 of row 1. 2 minus 2 times 1. That's going to be 0. That was the whole reason we did this exact operation. 5 minus -8 is going to be 13. 1 minus -6 is going to be 7. And then -12 minus 8 is going to be -20. Okay. Okay, so I've got the 0 there. Now the next thing I want to do is clear that 5 out. So how do I clear the 5? I'm going to do something very similar to what I did in that the most recent step, except now I'm going to take row 3 and I'm going to subtract some multiple of row 1 from that. In this case, it's going to be 5, basically a multiple of 5 of row 1. And then I'm going to put that back in row 3. So now I'm going to first just copy down the first 2 rows. 1, -4, -3, 4. 0, 13, 7, -20. And now the third row is the one that's going to be altered. So row 3, 5 minus 5 times 1, that's 0. So now I got the whole third column looking the way I want it. What is 0 minus 5 times -4? That's going to be +20. And then -2 minus 5 times -3, that's -2 plus 15, so 13. And then -13 minus 4 times 5, that'll be -33. Okay, so the first column is handled. Now we got to move on to the second column, or yeah, second column. So when you move on to a new column, the first job you have basically is to place the 1. So where this 13 is, I would like a 1 to be there. And like I said before, when we place that other pivot, that other 1 in the top left, we would really like to do that without involving more than 1 row. So I only want to manipulate row 2. So what can I manipulate row 2 by? Sorry, what can I multiply row 2 by to get a 1 there? Essentially going to divide everything by 13. So 1/13 of row 2 is going to go back into row 2. So first thing I'll do is put my 2 rows that I'm not changing back. And then what happens to row 2? 0 over 13 is 0. 13 over 13 is 1. 7 over 13 is 7/13. So very often, it's typically unavoidable. You're going to run into fractions. So we're going to have to be a little careful here going from here out, but that's okay. We can still get there. So -20 over 13. Okay, so now we got 4 of these elements set up. So now that I have a 1 in the middle of this column, I want to get zeros everywhere else in this column. So my next step, I'm going to clear out that -4. So how am I going to do that? I'm going to take row 1 and I'm going to add 4 row 2s to it. And I'm going to put that back in row 1. So what'll that give me? So again, let's just copy down the rows that aren't being manipulated. So 0, 13, 7, 0, 20, 13, -33. All right. Row 1 plus 4 of row 2. So one thing we don't have to worry about is because we already dealt with these zeros, that 1 we had in the top left is not going to be altered. But what is row 1 plus 4 of row 2? So what's negative 4 plus 4? That's 0. That's why we chose this. I made a huge mistake here by undoing things that we wanted to do. So 0, 1, 7, 13, negative 20, 13. All right, and this last column here, this is where we're gonna have to start having to be careful. We're gonna have 7/13 plus, sorry, negative 3 plus 4 times 7/13. So I'm going to use this space up in the margin here to kind of show my scratch work. So that's going to be negative 39/13. So that's negative 3 plus 4 times 7/13. So that's 28/13. This is negative 11/13. So 10, negative 11/13. All right, so then what's this next entry going to look like? Let's clear my scratch paper out. Row 1 is 4. That's 52/13 plus 4 times row 2. So that's minus 80/13. That gives me negative 28/13. So negative 28/13. All right, so again, got some nasty fractions involved, but sometimes that's inevitable, unless you can see another way forward without them popping up, but that's very difficult to do, especially if you're just kind of starting this process, but that's okay. So now we have this top middle 0. Now we want to get the bottom middle entry to be a 0. So I'm going to take a similar approach. I'm going to take row 3 and I'm going to subtract 20 row 2s from it. And I'm going to put that back into row 3. So what rows am I not dealing with? So 1, 0, negative 11/13, negative 28/13, 0, 1, 7/13, negative 20/13. All right, now that 0 is not going to change. So now I have row 3, 20 minus 20 times 1. So that gives me a 0, which is what I wanted. Next, 13 minus 20 of row 2. Okay, so let's go back to our scratch paper. So 13 is equal to 169/13. So effectively, I have 169/13 minus 20 times 7/13. So 169/13 minus 140/13, that gives me 29/13. So 0, 0, 29/13. And we got one more entry to go here before we, declare victory on this second column. So row 3 is negative 33 minus 20 times row 2 times negative 20/13. So what is 33 times 13? I'm not sure. 33 times 13 is negative 429. So negative 429. Right bigger, I guess. 29/13 plus 400/13. That gives me negative 29/13. So negative 29/13. So believe it or not, we're kind of done with the fractions. And hopefully, or not done, but hopefully what we have to do from here will not be as arduous. Because let's kind of look at the finish line again. My first two columns are now exactly what I wanted. 1 0 0 0 1 0. Now what I want, now that I'm onto the third column, I want to get that pivot to be a 1. So how do I make that pivot a 1? So my final row is 0 0 29 thirteenths negative 29 thirteenths. Basically, what I'm gonna do with this is divide that row by 29 thirteenths or multiply it by 13 29ths. So I'm gonna multiply that row by 13 29ths and put it back into that row. So what does that do? First two rows are going to be unaltered. 1 0 negative 11 thirteenths negative 28 thirteenths 0 1 7 thirteenths negative 20 thirteenths 0 0 20 actually no, if I'm multiplying 29 thirteenths times 13 29ths, that's going to be a 1. And what's the final entry going to be? That's going to be a negative 1. So hopefully we can see, we're kind of getting to the end here. In fact, I can say that C is negative 1. My solution for Z is going to be negative 1. So basically, we're very close to getting all of our solutions here. So now that I have that pivot, I want to get zeros in the two entries above them. So let's do the middle row first. Not that it matters. You can pick whatever one you want. But I'm going to do this. I'm going to take row 2 and subtract 7 thirteenths of row 3 from it and put that back into row 2. So let's just carry the bottom row. It's done. 0 0 1 negative 1. This first row we're not doing anything with. So 1 0 negative 11 thirteenths negative 28 thirteenths. What's the second row going to do? So the 0 and the 1 are not going to be altered. The 7 thirteenths there, that's going to be row 2 is 7 thirteenths minus 7 thirteenths times 1. That's going to be a 0. So we're getting really close. What's the solution then going to be? Row 2, negative 20 thirteenths minus negative 7 thirteenths. So let's go back to the scratch work. So row 2, negative 20 thirteenths minus 7 thirteenths times whatever's in row 3. That's 1. No, it's not, is it? It's negative 1. That's my mistake. So I get negative 20 thirteenths plus 7 thirteenths. That gives me negative 13 thirteenths, which is negative 1. So now I have my solution for my y variable is negative 1. So we only have one more job to do, and that is to clear out the negative 11 thirteenths. So last move here. I'm going to take row 1 and I'm going to add 11 thirteenths of a row 3 to it and place that back in row 1. So row 2 and row 3, 0 1 0 0 0 1 negative 1 negative 1 1 0. Okay. I want to take row 1, which is negative 11 thirteenths. I want to add 11 thirteenths times 1. That's going to give me a 0. So now we're looking at the solution space here. Row 1 is negative 28 thirteenths plus 11 thirteenths times row 3, which is negative 1. So I have a negative 28 thirteenths minus 11 thirteenths. That's going to be negative 39 over 13. That gives me a -3. So long way to get here, but now we have a solution. X equals -3, Y equals -1, Z equals -1. Okay, so after all that, let's move on to question 2. So hopefully, thankfully for you, I am not requiring you to solve this matrix by hand, but you do have to kind of develop all the equations on your own. I think the most important part of these is how you start. I'm not telling you what the variables are, not at least not explicitly. You kind of have to figure those out. So when I think about finding the variables, think about what you are being asked to know. What are you being asked specifically? So on a particular day, this theater sold a total of 8,500 movie tickets. And I also know how much money the theater brought in. I know how much each ticket costs. Given that twice as many student tickets were purchased, how many of each type of ticket was sold? So the thing you're really being asked about is how many of each type of ticket was sold. That should clue you into what the variables are, what the unknowns are. How many of each type of ticket? Okay, so what are the types of tickets? I'm going to call X. What's the first one they mentioned? Matinee tickets. Matinee tickets. What's another kind of ticket we sell? Matinee tickets, a student ticket. And Z is what? Z is just regular tickets. Okay, I have 3 variables, which means I need to build 3 equations. So what information is going to give me those equations? So now let's read this thing from scratch again. On a particular day, the Gilbert Majestic Theater sold a total of 8,500 movie tickets. Okay, I know that they sold 8,500 tickets, which means if I add these 3 unknowns together, X plus Y plus Z, that's equal to 8,500. Excellent. So that's one equation, and that came from 8,500 movie tickets. The next thing I know is that they all sold for a total of $64,600. So this equation does not care about how many or how much the tickets are worth, just purely how many people are sitting down watching a movie. Now I need to care about the value of these tickets. So what's a matinee ticket worth? Those are $5. So if I take $5 and multiply that by the number of matinee tickets I sold, and also multiply $6 times the number of student tickets I sold, and finally multiply $8.50 or 8.5 times the number of regular tickets I sold, that sum is how much money they brought in on that day. $64,600. So I got 2 equations. I need more information that will give me a third equation. Given that twice as many student tickets were purchased when compared to matinee tickets. Okay, so I know that the number of student tickets is equal to double the number of matinee tickets. So Y equals 2X. That's the third equation. So now I would like to put those in a matrix, kind of like the one I built above. So 1, 1, 1, 8,500. 5, 6, 8.5, 64,600. This last one's we got to be a little more careful with because it's missing a lot of information. One thing I'll point out is that these top 2 equations and all the equations we looked at on this matrix here, all the variable quantities are on the left-hand side of the equal sign, and all the knowns, like all the constants, were on the right-hand side. We don't have that right now. So can we rearrange Y equals 2X to look that way? I think we can. So basically, I want to get all my variable terms together, and all I have are variable terms. So let's do this. Let's move y to the right, and I get 2x minus y equals 0. So now let's put that into our matrix. Our coefficient of x is 2. Our coefficient of y is -1. There is no z term, so its coefficient is 0. And our constant term is 0. So I think this is a great matrix to help solve this equation. And like I said, I was not going to force you to solve this by hand. You definitely could. But we can do is this now. You know, if you search for, let me just show you what I search for, system of equations calculator, you get lots of options. Wolfram does lots of like tools that are valuable. System of equations calculator. Another thing we asked about is Gauss-Jordan calculator. So Gauss-Jordan is the method for reducing these matrices. So let's actually do that one. Gauss-Jordan. I'm going to take one of their templates. I'd rather just fill in a table. Yeah, so maybe I don't want to do this because I think that's going to be gotta be one that's a little more user-friendly. Here we go. So matrix dimensions. So number of rows, number of columns. 3 by 4 is what I want. So set the matrix, and then so I don't have to flip back and forth. Let me look at my notebook here. So we said it was 1, 1, 1, 8,500. Then 5, 6, 8.5, 64,600. And then 2, -1, 0, 0. Okay, so filled that in. If you want, you can get a very detailed solution, so it'll give you all like the steps. But let's see what we get here. So here's our solution set. It called our values x1, x2, and x3. We called them x, y, and z. But let's remind ourselves here, what did we call, like what were our variables here? So we got 900, 1800, 5800. So by the way we name these variables, those are going to be the solutions for a number of matinee tickets we sold, number of student tickets. So we sold x equals 900, y equals 1800, and z equals 5800, I believe. So let me just go back and make sure I'm remembering it right. Yep. So those are our solutions. And yeah, before I close this video out, I would be comfortable with doing both. On the first test, you are going to be asked to solve these both ways, but yeah, I wanted to show you one of each. One using technology and one going through it by hand. And we'll stop it there.